Okay, now that we've determined whether or not we have a triangle based on 3 lengths provided, let's talk about how we can determine what the length of a third side of a triangle will need to be if we only know 2 lengths. So here's the way this looks. What we're going to do is, here's a triangle, and we are looking for the third side of the triangle. We will call this a known side, so we can say that's side, and this is a known side. We'll call this the second side. And let's give this triangle a name. Let's call it triangle ABC. And you can see just looking at this triangle that BC is the larger of the 2 known sides. So what we're going to do is we're going to take the difference of those 2 sides, and we're going to compare that value to the sum of the 2 sides. And keep in mind, sides of triangles are essentially line segments, right? This is a segment BC, right? There's B, there's C. And so we're taking the length of BC, a known value, subtracting it from the length of AC to find what we call the small side, or the lower end of our range. And then we add the 2 pieces together to determine the high side of the range, which means that somewhere in between whatever this value is and whatever this value is will give us the length of, or a possible length of, that third side. So let's see what this looks like in an example with some numbers. Okay, the length of 2 sides of a triangle are 9 centimeters and 15 centimeters. Between which 2 lengths could the third side fall? So we'll just draw a quick triangle over here, and we'll give it a name DEF. And we know that one side is worth 15, and we know that one side is worth 9, and we're trying to determine what that third side could possibly be. So we take those 2 values and we subtract them to find the low side, and we're going to call whatever that middle ground is going to be X. And then we add the 2 pieces together on the other side to determine the high side of the range. So 15 minus 9 is 6, and 15 plus 9 is 24. So somewhere in between 6 and 24 will be the third side of the triangle. It's not going to be 6, and it's definitely not going to be 24, because we're not doing a less than or equals to sign here. It's just either greater than, meaning X is greater than 6, or X is less than 24. All right, so you can flip over to the back side of your paper now, and you will see a couple of different measures. We've got, to start with, the measure of the first side is 3, the measure of the second side is 7. So we're trying to determine that what the measure of the third side must be, somewhere in between those 2 values that we're going to determine given what they gave us. So it's 7 minus 3. We do the difference of the 2 to come up with the low end of our range, and then we add the 2 to determine the high end of the range. So go ahead and pause the video and take a moment and go ahead and fill in these other 6 columns based on or blocks based on the information provided over here. Okay, so you should have got what I have written down here. And you can see the range for our second triangle would be, or the third side of our second triangle would be between 7 and 17. The third one would be between 5 and 41. So you can see it's a pretty big range of what that third side might potentially be. The last one between 500 and 700. So it doesn't really matter the total number of how large the triangle could be, because we could have a triangle worth miles, with units of inches, whatever the triangle is that is in question, which kind of brings up this real life example. You can see here on a map, Richmond, Virginia Beach, and Norfolk form a triangle. Richmond is 120 miles from Norfolk, and Norfolk is 25 miles from Virginia Beach. which of the following is a possible distance of Virginia Beach to Richmond. So let's go ahead and draw a triangle to kind of designate where they're talking about. These three cities might live on a map. And let's name each of the vertices based on the first letter in the city. So there's Richmond, there's Norfolk, and there's Virginia Beach. We know that Richmond and Norfolk are 120 miles between each other, and Virginia Beach and Norfolk are about 25. We're looking to confirm what the distance between these two cities might be, what the range should be based on the triangle we're trying to form. So I'm doing the same exact thing I did above, and I'm taking those two values and I'm subtracting them from each other to determine the low end of that range, which would be 95. And then I'm taking the two values and adding them to each other and coming up with 145 as the high end of the range. And again, we can look at this as an inequality. X, or the location or the question mark that I wrote on that triangle over here, is between 95 miles and 145 miles. Somewhere in between will be the distance between Virginia Beach and Richmond. And based on the options we have, we can see 95 won't work for us because that's actually the low end and that's not part of our range. 145 is also not an option because that's the high end of the range. It's not part of the range. 52 is below 95, so that one will not work. We're left with 125 miles as a possible distance. And again, this is shown as possible distance. Someone might say, or the question might say, what is the range of the side of the third triangle? And that's often the way you're going to see items in the SOL. So let me leave this up here for a second. And let's go on to the next concept. We have, what is the relationship between the sides and angles of a triangle? In the last lesson, we discussed how a isosceles triangle has a relationship between its base angles and its sides. Recall we had an isosceles triangle, not a very pretty one, but nonetheless, if this guy and this guy are the same value, then we can walk across to the opposite angle, and we can know that those two opposite angles are also congruent. Well, in any triangle, we have a relationship associated with the angles and the sides, and it is as noted. The largest side is opposite the largest angle, the medium side is opposite the medium angle, and the smallest side is opposite the smallest angle. Go ahead and pause the video and write that information down in your notes. So let's see how this looks based on the triangle that you see in your notes. First of all, let's give this triangle a name. We'll name it triangle ABC. And let's give a couple of angle values to our triangle. We'll say that the angle formed at vertex B is worth 135 degrees, and the angle at C is worth 35 degrees. Now we know that the sum of the angles in any triangle is 180 degrees. So just like we learned in our last couple of lessons, we can determine what this third angle is if two angles are known. And that's really the first thing that everybody wants you to do if you have this on an SOL and you see two angles given to you in a triangle. Trust me, the SOL gods are asking you to determine what that third angle is going to be. So as we often say, if we know the total sum of the angles is 180, we could subtract the two values that we know to determine what the last unknown angle is. And in this case, 180 minus 135 minus 35 is equal to 10, or 10 degrees. So I'm going to write that in here. And now that I have some angle measures, what I want to do is notate which is the smallest, the medium, and the large. And the way I'm going to do that is I'm going to put an S, put a little circle around it, just because I want to make sure I know that's what I was trying to designate. It's not a 5, it means it's an S. My medium size angle is 35, so I'm going to write an M and circle that. My large angle is 135, so I'm going to put an L and I'm going to circle that. And make sure those are on your paper so that this makes sense as we proceed. So at this point, I'm going to make a path from the largest angle to the opposite side to determine where the largest side is located. Once I determine that it's this side, AC is the opposite side to angle 130, the angle that's worth 135, my largest angle, I'm going to put an L and put a circle outside of the triangle, somewhere about the middle, to designate that this is explaining the fact that AC is the largest side of my triangle. From the medium side angle, this guy, I'm going to walk across, have a little path, and then I'm going to write an M on the outside of my triangle, again to designate that AB is the medium-sized side. And then from my small side, I got a little path going to this side, because from the small angle opposite him will be the small side of my triangle. So again, we notate the fact that we've got segment AB. Remember, line segment AB is really what is creating the side of my triangle. And if I'm going to put these in order, the sides in order from greatest to least, then I'm going to say that AC is the largest, AB is the medium, and BC is my small side. So again, just to kind of confirm, this is from greatest to least. Make sure you write that down. All right, so that's pretty much how this plays out. I need to determine what my smallest, my medium, my large angle are, and that's going to tell me what the range, or the order rather, of the sides that I would know would be largest or greatest to least. And I don't know what the size of these sides are, meaning I don't know if this is 12, 10, and 8, but I do know that that is the order. Okay, so now that we have taken a look at putting the sides in order based on angle measures, let's do the same thing, but let's start with the sides. Go ahead and draw another triangle down below here. I'm cheating a little bit because I have a really cool tool that lets me draw a triangle. Let's give each of the sides a length. We'll say this guy on the bottom is 12, this guy over here is 7, and this side is 6. And while we're at it, let's give our vertices some names. All right, so pause the video if you need to get that drawn. And in doing so, as we did up here, we made circles around a small, a medium, and a large letter based on the angle measures. Here we're going to do the same thing, but it's going to be for the sides. So I'm going to start with my largest side. I'm going to put an L with a circle around him. I'm going to put an M and circle that M. And I'm going to put an S and circle it. And again, I like to circle the letters just to make sure I know that I'm talking about the letters associated with large, medium, and small, and I'm not confusing it with another maybe number or length. I start with the largest side. Let's do that. And of course, the largest side here is DF. And I'm going to walk opposite him to hit this side, which is, or rather this angle, which is angle E. And I'll put an L and circle that. And keep in mind, angle E is away from or opposite side DF. Since DF actually uses angles D and F, it's attached to that side, those two angles are not the ones that we're talking about. We're looking for the guy opposite. From the medium-sized side, I walk opposite him to find angle D. I'm going to put a little M in there. And then on the small side, I walk opposite him to find angle F. So I'm going to put an S and circle that. So now if I was going to put these angles in order from largest to smallest, I find where I put an L in a circle and found its angle E. So that would be the largest. The medium size will be angle D, and the smallest would be angle F, which looks like we lost our F somewhere in the midst here, but this is an F right here. All right, so that would be, again, we'll just talk about it from greatest or largest to least. All right, now go on to the next page, and you'll see some examples that I'd like for you to use And go ahead and try these on your own. You can see you've got 3 angle measures, so you want to start by marking the angles that are large, medium, and small, and then find the opposite side to the opposite angle. We'll start you with this largest angle in this triangle ADE, and you can see the opposite side is AE. And it asks for in this case, they're looking for shortest to longest. So make sure you read the question properly. Pause the video and then see if you got the same thing I did. All right, so you should have gotten the following for those 4 triangles. Again, shortest to longest here, so AD, then DE, and then AE. And again, we're talking about the segments which are making up the sides of our triangle. For DE, for instance, here we have point D and point E, creating the vertices of that triangle, which gives us those sides. And down here we're using angle markings, the symbols for angle, to show angle V is the smallest, angle M, and then angle O. All right, if you have any questions on that, please raise your hand and we will give you we'll take a look at it for you. If not, let's head back down to the bottom and the last real life example that we have to look at associated with our triangles. We've got a situation as such. We have a farm with with ducks, horses, and cows. And the farmer has each set of animals line up in a corral, forming a triangle. So let's start by drawing our triangle so that we can kind of see what direction we're going to take here. So here's a triangle, not beautiful, but one that we can use. And it's saying that we have ducks, and then the horses, and then we have the cows. So go ahead and draw your triangle and label the sides based on the animals. And what we're saying is that these ducks are all lined up in a row and so on and so forth. All right, so they have formed a triangle, and you can see that an angle formed by the horses and the ducks is 47 degrees. So here's my horses, here's my ducks. They're saying this angle here is worth 47. Let me change that color so it looks a little prettier. All right. This angle here is 47 degrees. They also say that the horses and the cows, here's my horses, here's my cows. The angle formed here is worth 102. And look at that, of course, they have not given us the third angle in our triangle. So go ahead and pause the video and let's go ahead and put in the third angle in that triangle based on what we know about the sum of the angles in any triangle. And you should have gotten that was 31 degrees. So we've got 3 angles formed with our animals, and it says here which orders the sides of the triangle from least to greatest using the type of animal. So same as we did above, we need to designate where our small angle is, where our medium angle is, and where our large angle is. And we can look opposite that angle to determine that we have horses that are the least, creating the side with the smallest side rather. Looks like cows is the medium size side. Let's put an S here to designate that. Put an M here to designate that. There we go. And then the large side is created by our ducks. You can see there's a multiple choice option here, and the answer is D.